Hello.
Good morning.
Good morning.
So Ben Horowitz, for those of you who don't know, he started out as a developer. So in his early days, he probably attended a lot of developer conferences like this.
Yes.
Became an entrepreneur and co-founder of Andreessen Horowitz. Came up with probably the best URL ever, A16Z.
Yeah, I've been copied a lot on that too.
And most recently, author of a best-selling book called The Hard Thing About Hard Things, which I highly recommend. Great read. And most importantly, for this context, he was early fan of Spark and a Databricks board member. So Ben, let's start with Spark. You saw something early on, and you were a fan, and you ended up investing in Horowitz, in Databricks. So what exactly did you like about Spark?
Well, it's interesting. You know, when I first heard about it, it was much vaguer to me than it is now. Now that I completely understand it, but in those days there were two things that kind of triggered me looking into the investment. One is we had a company we'd invested in called Clear Story Data, which had been using Spark. And they had been making super fast progress in terms of developing their application. And I said, well, why is it so fast? And they're like, oh, there's this thing called Spark, although I think they called it Sparky, or the CEO called it Sparky. And she was like, Ben, we're using this thing Sparky, and it's awesome. And I was like, wow, I had to take a look at that. I started to look at it, and then kind of separately, I got a call from Scott Schenker, who is a professor at Berkeley, who I know very well, and a very prominent professor in computer science. And he called me up and he said, Ben, I've got this project that we're working on. It's called Spark, and the architect of it, Matei, he's the best distributed systems guy we've seen the last 10 years in academia. And I was like, all right, that got my attention. As venture capitalist, when you hear that, you go, all right, where's my wallet? So that's how it got started.
So fast forward to today. So you weren't here yesterday, but there's a big announcement with IBM.
Yeah.
And as someone who's spent a large number of years selling enterprise software, that IBM imprint is important, right?
Oh yeah, so if you think about the world of customers, there's kind of customers that need to adopt new technology, and they know they need to adopt it for a competitive advantage. But then there's a kind of much larger set of customers who have a business that's pretty much working, and their main thing is to not screw that up, and so that's kind of on the risk-averse side of the curve. And it's very hard for them to buy something until a vendor like IBM says, okay, this is okay. It's kind of think of IBM as a rabbi, and it's this is kosher for use in your company, and it's blessed by the rabbi, and so now Spark is blessed by the enterprise rabbi.
So Spark, like a lot of the components in big data, is open source. And you guys probably hear a lot of pitches from the creators of these open source technologies.
Sure.
Some you invest in, some you pass on. So what's your thinking, and what kind of advice do you give to people who want to commercialize open source technology?
Yeah, so there's a few things. Open source is complex in that, one, it really helps to have the kind of original authors of the open source in the company, particularly if they're the largest contributors to the project, because the commercial success of it is very dependent on the kind of continued momentum as an open source project. And if you're not careful, you can either, one, fork it, and there was a lot of issues in the early days with ZenSource around that kind of thing, or it can just lose momentum entirely if you seize too much control of it. So that's kind of challenge one. The second challenge is, what is the business model? And kind of the most common business model is support. The challenge with that is support is a great business, probably one of the best businesses of all time if you're like Oracle and you have proprietary software, because in the market for support for Oracle has a monopoly. And so they charge as much as they want, and they raise money, raise prices on it whenever they want, and you still have to buy it. So it's awesome. What a great business. In open source, it's trickier because you're selling maintenance and support, but it's not a monopoly. And when it's not a monopoly, then depending on the nature of the competition and so forth, it can the pricing can get very, very competitive. And I think that great for customers, but tricky for investors and the people running the company. So you have to have a theory on how you can have enough differentiation and enough value add that you can still have a profitable business.
And actually, looking at your various investments, you've invested in 3 open source projects out of the AMP Lab, right? Spark, Mesos, and Tachyon. And you also have made a variety of investments in different big data companies. So is there a vision that you guys have for the next generation data center or big data stack?
Yeah, no, definitely so. So if you look at kind of our big data investments, you kind of have to start when you start investing in a category that's been around a while. Hadoop, I think, came out in 2005. That like, okay, are the hard problems solved, or are there still hard problems out there that we need to attack? Because if they're all solved and the new problems are incremental, then there's no need for new vendors. And in the Hadoop case, because it started in 2005 and the core problem it was solving was basically what are we going to do about SQL and its inability to scale, it kind of went forward with cloud computing of that era. And there were a lot of things in the cloud computing environment that weren't very well suited for big data. And so kind of MapReduce in particular worked around those. So if you start at the network, and at the network layer, in the bad old days, Cisco had this thing called the God box, right, which was oriented for traffic in a data center being northwest. So northwest being like out to the internet and back. But once you get to cloud computing and big data, like you start to get a lot of east-west traffic or within the data center. And so kind of that's the kind of first thing that had to be fixed. And MapReduce sort of worked around that by saying, look, we're just going to process the data at the end nodes and we're not going to have much communication and we'll just deal with it. But now, like, there are companies like Cumulus, which we invested in, which kind of make east-west traffic kind of much faster and much more manageable. Then you kind of move up the stack and you say, well, the next thing they had to deal with is kind of virtualization and the hypervisors. And the hypervisors, was a great thing if you were going to have like 8 different things run on a computer, then you have a virtual machine, like pretty heavyweight for everything. But if you're running 1,000 nodes and they're all running Hadoop, then a hypervisor isn't necessarily what you want. You don't want like one machine that looks like 10. You want 1,000 machines that look like one, and that's Mesosphere. And then you kind of move up to the next layer and say, okay, well then what about storage? And of course, in 2005, we're talking about disks and distributed and so forth, and now we're moving much more to kind of a hyperscale in-memory architecture. And so from a file system standpoint, memory needs to be kind of dealt with as much more of a first-class citizen, and that's Tachyon. And then that all enables kind of a new database or a new kind of interface layer where you can replace MapReduce because you've got an infrastructure that kind of works around a lot of the challenges with it, and that is Spark. And then if that all sounds really complicated, which it probably does, then you can just go with Databricks Cloud, which makes the whole thing simple. And so that's my investment strategy. But I think that the really profound thing that happens when you move from kind of the old infrastructure to the new one is you go from sort of reactive batch kind of reporting to proactive real-time analytics, machine learning, and AI. And that is kind of where you get to really new, exciting applications, and we've made some investments there. So, Platfora, one of the early real-time analytics companies, and Datao, which is doing really fantastically interesting things with integrating machine learning into applications. So that's kind of it in a nutshell. Yeah. So it's a lot of technology to.
So actually, speaking of the cloud, people may not know, but Ben was early pioneer in cloud computing with his startups, Loud Cloud and Opsware. And in fact, coincidentally, I spoke to some of the engineers at both companies recently, just coincidentally, and they were lamenting just the whole timing thing, right? So if Loud Cloud and Opsware were around now, we'd be killing it, right?
Yeah, darn.
So
we started AWS in 1999.
So you look at the enterprise adoption for the cloud. So what are you seeing as an investor?
Well, so the cloud is just, like, one, it's a lot better now than it was when we started Loud Cloud. So Loud Cloud was like pre-commodity hardware, pre-virtualization. That made the economics challenging, let's just say. And then there was the whole bubble thing, which turned out to be problematic. But now, the cloud architecture is really advancing, which is making the solutions very, very powerful. But ironically, the kind of thing that slowed cloud adoption for years is the thing that's really accelerating it now, which is security. And I think that, what people are finding as kind of security has escalated from vandalism to theft to war, that like building an infrastructure that can combat a nation state is not really viable for almost any company. If JP Morgan Chase can get hacked, then like you're probably gonna be vulnerable. And so, the people who are dedicated to it and are hiring the best security experts in the world and running cloud computing environments, you actually, there's now an argument that like security in the cloud is even better. And then when you get into the big data world, well, like your data is interesting, but your data plus the data in the world on the internet is way more interesting. And so if all the data on the world is out there and in the cloud, then it starts to make sense architecturally to move your data there too. And so, we're starting to see that. And as a result, this has been like a giant year of momentum for cloud computing.
You used the B word, bubble. So are we in a tech bubble?
Are we in a tech bubble? So the fact that you're asking me that question means we're probably not, just because a bubble is an investing bubble is a psychological phenomenon. It's when like everybody believes that now the world is different and it's going to continue forever. That's when you get to a bubble. And so if he's asking me that, that means he doesn't believe it. So we're probably not in a bubble. That's my flip answer. We actually have a presentation on our website right now that does a very thorough, over 50-slide data analysis of are we in a bubble or not. And I would just say that we're almost certainly not in a public market technology stock bubble. If you look at it, it's impossible to really look at the data and say we're in a bubble in the public markets. In the private markets, there's a little more of an argument for it. But a lot of the data points that people cite, I think, are, they'll take one data point and say, oh, that's a bubble. Like, oh my God, there's more tech unicorns, meaning, tech companies worth more than $1 billion that are private than ever before, therefore a bubble. But, if you look at it more closely, what you can see in the data is that companies are going public way later in their lifetimes than they used to. And so it would make sense that there would be more that are valued at over $1 billion because they're going public when they're worth more than $1 billion, whereas the companies of the past, like, say Microsoft went public when they were worth $300 million, and Facebook went public when it was worth $70 billion. And so this is a new world, which is a result of a lot of regulatory changes and other things. And I think when you net it all out, I would say we're probably not in a bubble yet, but there are some fairly scary signs that we have to keep track of.
So that's good, because you guys keep investing in the data space. And just this morning, I was talking to you backstage about this interesting company, SignalOpt. But generally, are there any untapped opportunities in big data that you think people are still overlooking at this point?
Yeah, so I think that big data is actually far bigger than even the hype, in the following sense that it turns out that humans are super bad at making decisions, which I didn't even realize. I read this book, Thinking Fast and Slow by Daniel Kahneman. Yeah. Some of you probably have read it. But it is amazing. So just a kind of short story on it is there are two systems of thinking for humans, like instant reactions, like bear, run, like that kind of system. And then, okay, here's a hard math problem, solve it. And it turns out that most people never use the second system, ever under any circumstance, and always avoid it. To the point where, he did this thing where he showed people, pictures of political candidates for less than 1/10 of a second. And the people looking at that picture for less than 1/10 of a second could predict the winner 73% of the time. So people pick the political candidates literally on like a 1/10 of a second judgment on how they look. Oh, that guy looks honest, voting for him. And so like that's the current state of the art in decision making. So you can imagine like all the opportunities for machines to do a better job. And like a really good example of this is I was talking with Christopher Nguyen, who's the founder of Daytao. And he said, like machine learning, we're at the point now where we can solve like problems that have dogged us for years. If you think about blind SQL injection, which is the kind of the easiest way to break into anything, because somebody doesn't validate their inputs when writing a database application, you can just put a query in there and snatch all their data. And the only way around it to date has been for every human programmer to like not make that mistake, and the chances of that happening are like 0. I mean, like absolutely 0. But with machine learning, you could have the machine take a look at the inputs and say, wow, that looks like a pretty crazy, your age is like, whatever, question mark, blah, blah, blah. That doesn't seem like an age to me, and could reject those queries kind of automatically. So that's the kind of thing that I think we can look forward to as, pervasive machine learning across applications.
So our time is up. I just wanted to compliment you on the book and ask you, is there going to be a sequel?
Well, I could write it about like venture capital investing in the bubble. It could be called The Easy Thing About Easy Things.
That's all we got. Thank you, Ben Horowitz.
Okay, thank you.